Welcome friends once again to our module on exploring healthcare survey data as part of NPTEL MOOC program. This has been one of the successful venture of Ministry of Human Resource Development or the Ministry of Education. This has given a wonderful platform to the scholars, especially during the COVID-19. Where we have tried our best to cater to the need of our students as well as our researchers. Being in I.I.T, I have tried my best to read, go through and shape of documents with the help of our team. In this team, we have Mr. Milin and Mr. Kamal, who have been continuously supporting in making PPTs, in supporting document, and in supplementary document, running softwares, operating some of the programming of it, okay, and clarifying some of the anecdotes wherever it is possible, and that has made us in coming up with a systematic record of record of the lectures explaining this particular module. This time, as I already told you, we have had already earlier one program on large scale survey data. This time we have focused our best on the healthcare data, and we know that healthcare is too important in the present days, and it needs special attention from the researchers and the policymakers, and based on that we have structured our program in such a manner that we can get use of the data, and at the end we try to give the best icing on the cake, that is the applications part, where you guys can able to link your data for direct policy making purposes, for her policy recommendation purposes. Like most of the research papers nowadays in their review, they get the comment how far your result are linking to the reality, or how far it is implicating the society. That is why our last module is targeted, and we have been discussing about policy evaluation in healthcare. Though detailed practical sessions are not possible because this consumes time, as well as it requires certain expenditure to run some pseudo experiments. So we haven't done that, but at this moment we have come up with conceptual clarity with some practical examples. Okay. So now this is in fact our last lecture. Here we will be emphasizing on the latest module that is used by the researcher called regression discontinuity method. Here you may see that the word, you will certainly find out the word called discontinuity. Discontinuity means as if something is going on, there is some sort of sporadic changes, some sort of deviations. So a person who checks very minutely can able to find out, yes, changes are very sporadic or changes are very insignificant. When you have captured a specific point, like a poverty line for example, from that line how far changes are observed, whether those are at the border are very close to the poverty line, or those are above to the poverty line are also close to the poverty line. What kind of changes are there? So the regression basically going to estimate about these coefficients that is deriving those changes, emphasizing yes, change is very high, then accordingly we might have different policy implications. So based on that logic, we have come up with the presentation before you, and I know that this is the last lecture, but that is not completing. We will also come up with next time a detailed version of it, and till that we are trying to explain this. So let us go for it. Here it is, regression discontinuity design, in short called RDD, is a quasi experimental impact evaluation method, and this is used to evaluate programs which have a cutoff point determining who is in fact eligible to participate in a program or not. This RDD allows researchers to compare the people immediately above or below to the specified cutoff point we mentioned or identified that has impacted the program on a given outcome. The method was first used in 1960 by Thurslethwaite and Campbell. They were interested in identifying the causal impacts of merit awards assigned based on observed test scores on future academic outcomes. I repeat that these authors have interested in identifying the causal impacts of merit awards assigned based on the observed test scores on future academic outcomes. Basically, the test scores on the basis of that whether it has impacted the future academic outcome or not have been checked and also cited by Lee and Lemick's 2010 paper. Researchers have used it to evaluate electoral accountability, SMEs policy, social protection programs such as conditional cash transfers and educational programs such as school grants, etc. RDD is a key method in the toolkit of any researcher who is interested in exploring the causal effects of policies. Now, this time the Nobel Prize has been awarded to or is awarded to the persons who worked on causal inferences. Okay, so therefore, their document you can also read along with this basic guidance. RDD, the assignment of treatment and control is not random, okay, but rather based on some clear cut threshold. So, this has to be highlighted. So, these are not random. So since it is focusing on the cutoff threshold point, so it cannot be random, and that cutoff point are based on the observed variables such as income, age, scores, etc. In the context of an evaluation study, the RD design is characterized by a treatment assignment that is based on whether an applicant falls above or below a cutoff point on a rating variable. This generates a discontinuity in the probability of treatment received at that particular point. So, RD analysis can be characterized in at least two different ways. First is called discontinuity at a cutoff point, and second is local randomization. So, two way by which the discontinuity is observed. Those are suggested by the author we have cited here. You may just read and you can also go through their reading in detail. The two which we have just said, local treatment based method, second one is as I already said based on the cutoff point. Okay. So, first one is called the cutoff point, second was local randomization. The first characterization of RD analysis is called discontinuity at a cutoff point. So, that focuses on the jump shown in the bottom paragraph in this particular figure. So, you can just see how there is a clear cut jump from the cutoff point, and these two ways characterizations of discontinuity analysis is presented, and every time in the first case we say in the absence of treatment, and in second one in the presence of a treatment. When there is an absence of treatment, okay, how in the absence of treatment we see that there is no such sporadic change or deviation, where in case of with treatment there is a clear cut off jump, okay, and that is what is important to be discussed. The second characterization of RD analysis is called local randomization, which is based on the premise that differences between candidates who just miss and just make a threshold are random. Okay. So, local nearest randomization. So, they just make a threshold at a random point, but in the previous case those are not at all random. Candidates who just miss the cutoff point are thus on average identical to those who just make it, except for exposure to treatment. Any difference in subsequent mean outcomes must therefore be caused by treatment. In this case, one can simply compare the mean outcomes for schools just to the left and just to the right of the cutoff point. Now, we are citing studies, those are using RDD regression discontinuity design, like Wilbert, one day Clow 2002, and Joshua Angrist, Victor Levy. Angrist is quite famous in this particular approach. They exploited threshold rules which often used by local or by educational institutions to estimate the effect of financial aid and class size respectively on educational outcomes. RD design is used to answer a range of questions, that is, for example, the labor supply effect on welfare, unemployment insurance and disability program, the effect of Medicaid on health outcomes, the empirical relevance of median voter models, etc., are usually tested. RDD for health policy evaluation is also quite important. RDD has been used by exploiting the discrete change in health insurance coverage rate at age 19 to investigate the relationship between health insurance coverage and insurance status of young adults, as you can also read in the paper by Roorkee 2016. There are some conditions required for the RDDs to be effective or to be applied. First of all, to apply RDD, the following main conditions must have been met. That is, the index must rank people or units in a continuous or smooth way. Indexes like poverty scores, test scores or age have many values that can be ordered from small to large, and therefore, they can be considered very smooth. Okay. Second one is, by contrast, variables that have discrete or bucket categories that have only a few possible values or cannot be ranked are not considered smooth. So, there are two maybe smooth or not smooth, like employment status, country of birth, car ownership, number of visits to the doctors, etc. The index must have a clearly defined cutoff score, that is a point on the index above or below which the population is classified as eligible for the particular program. Here we are citing one example, like household with a poverty index score of less than 50 out of 100 might be classified as poor. Individuals with age 67 and older might be classified as individual, may be eligible for a pension. This varies from country to country. It might be 65 and above. Some country might state 67 and above. The cutoff scores in these examples are 50 and 67 accordingly. So, based on the program where you want to find the impact of their changes, you can also look at, like for example, in healthcare access, like the healthcare treatment where people can go for it, you may check through their standard of living. You can based on your guesstimates or based on the prior experience, you can set a standard of living, that from that benchmark what kind of changes are observed, whether they are actually going for treatment or different type of treatment or not from that cutoff point. So, the cutoff point must be unique to the program of interest, that is therefore, there should be no other programs apart from the program to be evaluated that uses the same cutoff score. So, simultaneously another program that is being studied should not be actually compared and should not be mixed. Okay. For example, if a poverty score below 50 qualifies a household for a cash transfer or health insurance, a free public transportation or for a free public transportation, we would not be able to use the RDD model to estimate the impact of the cash transfer program by itself. Okay, because if you are simultaneously looking at more than one program, RDD program may not capture the changes very clearly, the discontinuity cannot be captured. The score of a particular individual or unit cannot be manipulated by the enumerator, potential beneficiaries, program administrator or politicians. Therefore, we have certain assumptions to validate about the cutoff points. The eligibility index should be continuous around the cutoff point. So, the data that we are referring near by the cutoff point must be continuous enough. There should not be no jumps in the eligibility index as the cutoff point or any other sign of individuals manipulating their eligibility index in order to increase their chances of being included or excluded from the program. When we are saying poverty line, people should not be clearly excluded to mark the differences. Like if you are saying age group of a particular age, when you know that these ages are completely separated out and you have stick to a particular age group to differentiate, then probably you are not capturing the right direction of your evaluation. So, you have to take a cutoff point that should not by assumption differentiating the two. Okay. So, there must be certain continuity in the expected frequencies. The macro density test tests this assumption by checking eligibility index density function for continuity around the cutoff point. Okay, you can also follow this Macquarie density test. Individuals close to the cutoff point should be very similar on average in observed and unobserved characteristics as well. In the regression discontinuity framework, this means that the distribution of the observed and unobserved variables should be continuous around the threshold point. Now, we are differentiating two important type of RDD. One is called sharp RDD, another is called fuzzy RDD. So, some units that qualify for the program on the basis of their eligibility index may opt not to participate, while other unit that did not qualify for the program on the basis of their eligibility index may find a way to participate anyway. So, like for example, we have a group which is not eligible, but we have forced them to be eligible. Okay. Another one is actually eligible, but our cutoff point is defined in such a that they are not ultimately end up with non-eligibility. So, that may create certain problem. When all units comply with an assignment that correspond to them on the basis of their eligibility index, we said that RDD is in fact very sharp. Okay. When we comply all these assumptions following following the way we wanted to define like an eligibility and the exact acceptability of that cutoff point. If there is a non-compliance on either side of the cutoff, then we say that RDD, like you have defined the cutoff point, but actually it is not compliant to the portions that have been considered. So, that way it is called fuzzy. Here is the chart that clarifies. First one, in both the case we are trying to explain through the baseline poverty index. In the first one related to the sharp RDD as where full compliance has been covered. Full compliance because it has a very clear or clarity whether they are part of the program or whether they are not part of the program from the cutoff point. Okay, it has a clear binary series. Where in the next one related to fuzzy, there is a increasing or decreasing trend in either of the axes. They are not clearly defined. Okay, so incomplete, that is why they in the fuzzy RDD they are called incomplete compliance. The way we wanted to cover is not clearly close to 1. Okay. So, 100% or 0 is not well defined, but in the fuzzy it is not defined correctly, as I already said it. Now, I am coming to the clarification related to the conditions for internal validity of those compliance. As RDD is a non-experimental approach, it must meet variety of conditions to provide unbiased impact estimates and to approach the rigor of a randomized experiment. Specifically, the rating variable cannot be caused by or influenced by the treatment. Okay. So, the rating variable should not be actually caused by this treatment. The cutoff point is determined independently of the rating variables. That should be exogenous. And assignment to treatment is entirely based on the candidate's rating and the cutoff point. Nothing other than treatment status is discontinuous in the analysis interval, that is there are no other relevant ways in which observation on one side of the cutoff point are treated differently from those on the other side. The functional form representing the relationship between the rating variable and the outcome, which is included in the estimation model, is continuous throughout the analysis interval absent the treatment and is specified very correctly. Now, how to interpret all those differences? RDD estimates local average treatment effects around the cutoff point. So, that is what we have given the disjoint chart, where around the cutoff point is interpreted with local average treatment effects, where treatment and comparison units are most similar. The units to the left and to the right cutoff look more and more similar as they near the cutoff. Given that the design meets all the assumptions and conditions outlined above, the units directly to the left and directly or the right of the cutoff point should be so similar that they lay the groundwork for a comparison as well as does randomized assignment of the treatment. Okay. Because the RDD estimates the local average treatment effects, that is let around the cutoff point or locally, the estimate does not necessarily apply to units which scores further away from the cutoff point. Okay. So, away from the cutoff point not necessarily going to be applied the way we are explaining at the cutoff point. We do not estimate the effect of getting the treatment, but rather the effect of getting the treatment for units where close to C, that is the cutoff point, not everybody in the sample, those are at maximum to the local point, not extreme to the cutoff point are discussed. RDD is inability to compute the average treatment effect for all the program participants in both a strength and a limitation, strength and limitations depending on the question of interest. Since it is not covering all participants, so it has its strength and it has its limitations as well. If the evaluation primarily seeks to answer whether the program should exist or not, then the RDD will not provide a sufficient answer. It is not giving the complete evaluation of the model, it is giving a particular focus whether it has implicated at the cutoff point or not, at a specific people or not. The average treatment effect for the entire eligible population would be the most relevant parameter in this case for estimation. However, if the policy question of interest is whether the program should be cut or expanded at the margin, then the RDD would of course give the precise estimation regarding those local estimate of the interest to inform these important policy decisions. Therefore, we say that if policy decisions are very focused and very pointed, that it giving explanation at the margin, then the result would be quite appropriate through the RDD. Otherwise, you need not apply this technique. Okay. So, these are all for our lectures so far. Now, I am just giving you a snapshot of what I have discussed so far in entire 40 lectures. There are different weeks, we have 8 weeks module. From the starting weeks, we try to get your attention on how to develop research paper, how to have a understanding on understanding research gaps or understanding the basics of research. Then we tried developing your understanding on what are the different healthcare data available in India. We emphasize about longitudinal data as well, okay, including NFHS data, NSS data. Then we tried our best to give detailed explanation about survey tools, survey techniques, there are missing records, entering data in different formats, okay. And also we discuss about questionnaire, then schedules carefully, okay. After that, we also emphasize about different types of data and how they are stored, what are their measurement techniques, sampling design very correctly, okay, how to take a small sample out of the total sample. Okay. After that, we explained about different stata tools, stata how stata can be understood correctly, stata commands, we reviewed all the commands, including we talked about you know the qualitative dependent variable models, the quantitative models. Okay, we discuss about all possible degrees of fitting the model, like the base fit, how we can define whether r square, capital R square, r bar square, that is adjusted r bar square, pseudo r square okay, etc. We discussed in detail. We also try to develop your interest in explaining comparing each of the models and their R square values, okay, including tobit, probit, etc. Then last 2 weeks we tried to focus on the panel estimations, okay, panel estimations and program evaluations. This week, as we already have seen, it is completely on program evaluation. The previous one is, the penultimate one is on the panel estimation. We have focused our best to give you the right direction in the healthcare data to understand which panel model should be applied and why to apply, what are the best interpretation of it. I think these are all in 2-3 minutes capsule. I have tried my best to set in your mind. Our team is quite dedicated to give you the right direction further in our live session. I suggest everyone to raise your pen and start writing to us in our query section. Also, we will be very happy to address all your queries in our live session as well. With this, wishing you good luck, and I am sure that you will cover all the units very carefully and can able to score well and go for the test. Good luck. Thank you.